Welcome to a special installment in my series, Writing a 6502 Assembler in Assembly Language. I'm recording this right after installment 13, in which I wrote a binary search to search a table of keywords to see if a symbol, which has been recognized by the scanner as a name, is actually not a symbol, but a keyword. And I have made this little diagram to help describe the code. Let's look at the actual code here. First off, we have a bunch of strings in memory, and each of these strings has a label in front of it, which gives us the address of that string. So this KW03 label is the address of this dot right here, the address of the byte, which represents this dot. And we can see these represented in this diagram here on the side. If we go down, we now have this table, which is labeled with keywords. And at the end of the table is e-keywords. And this table contains all of those labels up here. That is to say, it contains the addresses of the strings. It contains pointers to the strings. You could think of it that way. And we have that also here. Here is our table of pointers to the strings. And keywords is the address of the first pointer, and e-keywords is the address just after the last pointer. Notice e-keywords is not the address of this pointer here, it's the address just after it. Okay, and then we have these two 16-bit variables, which are also pointers here, is KWF and is KWB. And I've represented them here, is KWF, is KWB. And what these do is these will contain pointers to the begin and the end of the part of the table that we are looking at to find our name, to see if it's a keyword. At the beginning of the binary search routine, is KWF is equal to keywords, and is KWB is equal to e-keywords, because we're searching the entire table. The entire table is under consideration to find a symbol. All right, so let's assume that we are looking for the symbol ASL. The scanner has read a name. It says, I've read a name, ASL, and it's going to try to find it in the table to see if this is actually a symbol or if it's a keyword. Of course, it's a keyword. We can see it right here. It's one of the instructions for the 6502. So at the beginning of the is keyword function, right here, what we first do is we set up is KWF and is KWB to be keywords and in keywords. All right, then we have a loop. What this loop does is, first off, the loop has to calculate a value for is KW2. And it does that by taking this pointer and subtracting this pointer from it. So like is KWB minus is KWF. And what that gives us is the number of bytes in the table, in the part of the table that we're looking at. And at the beginning of the first time we go through the loop, it's the entire table. But as you'll soon see, it will get cut down rapidly, and we'll search smaller and smaller pieces of the table until we find the word that we're looking for, or we don't find it. Okay, so this is the number of bytes between here and here. And my example here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 entries, or 20 bytes, because each one is 2 bytes long. So this would give us 20. We're trying to find the middle of the table, so we divide by 2. All right, so divided by 2 gives us the middle of the table. And now it's very important that this basically now represents an offset from the beginning of the table, which is the first pointer that we're going to consider. It's very important that this offset be an even number, because each of these entries is 2 bytes long. So if the offset from the beginning of the table were an odd number, that would be somewhere in the middle here, which is no good because I can't take this byte here and this byte here and make a pointer out of it. That would not be right. So what I do is I clear the low bit of this calculation by ending it with FE. That clears the low bit. Okay, so this will give us now an even offset into this table. And then we take that result and add it to is KWF. And that changes it from an offset to an actual pointer. So in this case, we have 10 entries. That's 20 bytes. So is KWB minus is KWF is 20 divided by 2 is 10. Clearing the low bit, it stays 10. And then we say is KWF plus 10. All of this is the new value of is KW2. And that would be, in this case, this plus 10. So that means right here, 2, 4, 6, 8, 10. So it's pointing to this pointer right here. So this is pointing here. So now what we do is we compare whatever this thing is pointing to, which in this case is the BEQ string, with the string we're looking for, ASL. And we find that BEQ is greater than ASL. That means alphabetically comes after ASL, which means that since all these are in alphabetical order, that means that we can now exclude this and everything after it from consideration. We don't have to worry about those at all. So to do that, what we do is we move this thing here to point up here to the same place as is keyword 2. That means that from now on, we're only considering this part of the table here, these entries. And now we go back to the top of the loop. When we go back to the top of the loop, we simply have to do this calculation again. And here we have 1, 2, 3, 4, 5 entries. That's 10 bytes. So this is 10 divided by 2 is 5. And now this comes into play. 5 has a low bit of 1, so this will clear that off and make it a 4. So is KWF plus 4? That would be 2, 4 right here. So that means this is now going to point here. That means it's pointing to the entry which says ASL. And now we compare what we're looking at with whatever this thing is pointing to and ASL. Ah, we found it. So good, we've recognized that ASL is a keyword because it's in the keywords table. Right, I just changed this to ASCII. Let's assume that the code has that we're assembling has a variable called ASCII. So everything would be the same up to here, to this same point, and it sees it's now comparing ASL to ASCII, and it says, they don't match. And in fact, ASL comes alphabetically after ASCII because it has ASL, whereas this has ASC. So again, that means that this part here would now be excluded from consideration, which means we're going to move this here. And now we go back to the top of the loop and we have to recalculate this thing here. So now is KWB minus is KWF is 4 bytes, 2, 4. Divided by 2 is 2. Clear the little bit doesn't change anything. So now we add 2 to is KWF, which means right here. And this gets moved there. So now is KW2 is pointing at the pointer, which points to AND. We now compare AND and ASCII. And we say, aha, AND is before ASCII alphabetically because it starts with AND, whereas ASCII starts with AS. Okay, so now we're going to move not this one, we're going to move this one. And what we're going to move it to is we're going to move it to the thing after this here, right? Because last time we have this and this, we're considering everything between this arrow and this arrow, that is these two entries. So if we moved this, and before we just moved this to whatever this was, if we did that here, we would move this to here, and we would still have one entry under consideration. But we considered this entry last time. Last time we were looking at these two. So we don't want this entry to be under consideration. So instead, whenever we adjust is KWF, we move it past is KW2 like that. And now we go back to the top of the loop. But the first thing the top of the loop does is it checks to see if is KWF and is KWB are equal, and they are. If they are equal, that means we did not find our name in the table. And so we return and say, no, this is not a keyword. Okay, I hope that helps you to understand how this binary search works, because I think I was explaining it while I was writing the code in episode 13, but also, there were bugs and things had to be fixed, so it may not have been super clear. I hope this makes things a little bit more clear.